Assalamu alaikum. Welcome to the next lecture. In this case, we will see how this load flow problem can be first identified and then how it can be solved. We know that the important result we have derived, that is this II, that is the current injected in bus, will be given as summation of J from 1 to N Vj Yij, where Vj is the bus voltage and Yij are the uh, Y bus elements. They are defined by the value of I and J. At any ith bus, the complex injected power is given by simply SI, which is equal to PI plus JQI, which is equal to VI into II star in terms of voltage and current. This we know. So taking the complex conjugate of the whole equation, we get SI star will be equal to PI minus JQI, complex conjugate of this, that will be equal to complex conjugate of this, complex conjugate of double conjugate of this, it will be II. VI star into II. So Pi minus JQI will be equal to Vi star into II, and this II can be replaced by this equation. It will be equal to summation J equal to 1 to N Vj Yij. So let's say this is equation 2. Now separating the real and imaginary part, you can see that I will zoom it a little bit. Pi will be equal to real part of the equation, that is Vi star into summation of J equal to 1 to N Vj Yij. Qi will be equal to minus imaginary Vi star summation J is equal to 1 to N Vj Yij, and you know that because we have the equation Pi minus JQi, that minus we have taken over here, we can say that minus Qi will be equal to imaginary of this, that minus has been taken to this, it will be equal to minus imaginary of this equation, whole equation. So let Vi is equal to magnitude of Vi at an angle of delta I, that is equal to Vi angle of delta I, that I have dropped over here these two. When angles are mentioned, this means Vi will be the magnitude of Vi, not the actual phasor. So it will be Vi at an angle of delta I. Similarly, Vj will be equal to Vj at an angle of delta J. Yij will be equal to magnitude of Yij theta Ij, that is the admittance angle, Yij theta Ij. Put these values in this equation. So Si will be equal to Vi star. That Vi star will be equal to complex conjugate, and we know that when we have to calculate the complex conjugate in polar form, we just have to negate the angle only. So here it will be Vi angle of minus delta, then summation Vj angle of delta J, Yij angle of theta Ij. So in case of complex numbers, when they are in polar form, their magnitudes will be multiplied in case of multiplication, and their angles will be added in case of multiplication. Since it's a multiplication, angles will be simply added, and magnitudes will be simply multiplied like this. So here, simply writing in terms of their rectangular form, it will be Vi summation of J is equal to 1 to N Vj Yij cos of minus delta I plus delta J plus theta Ij, like this, plus J times Vi summation Vj Yij sine of minus same angle. So this is Pi minus JQi. Now separating the real and imaginary parts, Pi will be this part and minus Qi will be this part. So I will separate them like this. Separating the real and imaginary part, Pi will be equal to Vi summation of J equal to 1 to N Vj Yij cos of minus delta I plus delta J plus theta Ij. So I can take the minus common. So it will be equal to plus theta I minus delta J minus theta Ij, because cos of minus theta is equal to cos of theta. Here there will be no change, only angle will be changed. So I can write it in this form or in this form, because I wanted to take it in this form because I wanted delta I to be first and it should be positive. So it will be like this. Similarly, Qi will be equal to minus times Vi summation of Vj Yij sine of minus delta I plus delta J plus theta Ij. Similarly, I will take minus common, this minus, or I will consume this minus to this and use this identity, sine of minus theta is equal to minus sine theta. I'll consume to this, I'll multiply this minus to this angle, I will get it theta delta I minus delta J minus theta Ij, and there will be no more negative here, it will be positive. So these two equations will be the power flow equation which we need to solve to get the different quantities. So I can say that the equation 5 and equation 6 are known as the load flow equation or static load flow equation, SLFE. That is, this Pi is equal to this, Qi is equal to this. These are known as static load flow equations. Now, the important points about the static load flow equations. It means at each bus we have two equations, that is Pi and Qi, that is equation 5 and 6. Therefore, for an n-bus system, we have two n equations. For one bus, we have Pi and Qi, and for n bus, we will have two n equations. But at each bus, we have four variables, that is Vi, delta I, Pi, and Qi, which we have discussed earlier. And for these values, we do this load flow analysis. And for n bus system, we have four n variables. So there is a mismatch. Why there is a mismatch? Because for a solution of the equation to exist, we should have variables as many as equations. So the number of variables and number of equations should be equal to have a solution of the equations. But here we have mismatch in the equations and the solution. So to counter that, at every bus, two variables are given. The two remaining can be found by the equation. So at every bus, two variables are given and two are calculated. So it is because of this, then we can be able to find the solution of the load flow. Otherwise, it is very difficult because we have four variables and only two equations. So to counter that, at every bus, two variables are given. So based on this, based on the two variables given, buses are classified into four categories, generally in four categories. So one is the slack bus. It is also known as swing bus or reference bus because all the voltages are referred to this slack bus. These are the three names: slack bus, swing bus, or reference bus. We have PV bus or generator bus, the buses to which the generators are connected. This bus also we have generator connected to this, but there is a slight difference from this to this. We make this bus as a reference. Why PV bus, PQ bus? We'll come to know this in just a minute. PQ bus is the load bus to which the load are connected, and voltage control bus is the bus at which the voltage is controlled by some device. So specified variables at each bus depends upon the what device are connected to the bus. So here, as I told you, voltage control bus, it is a bus at which some devices like capacitors are connected, so it is known as voltage control bus. Here it is the bus and specified values will be, because here the loads are connected. Here two types of buses. Here generators are connected. I will first discuss the slack bus, swing bus, or reference bus. In this case, Vi is specified. Generally, it is taken to be equal to 1.0 per unit, or it may be sometimes different from this, but it is given. But in most of the cases, it is taken to be 1.0 per unit. So delta I is specified and it is taken to be 0 degrees because it is taken to be reference. That's why it is also known as reference bus. So these two are the known variables, and unknown variables for this bus will be Pi and Qi. They are the known variables. So the number of slack buses is only one. Even if we have 1,000 buses, 10,000 buses, slack bus, that is the reference bus is taken to be only one. A generator, this is also, in this case, a generator is connected to this bus. The slack bus have a generator connected to this, but the generator with the maximum capacity is usually taken as a slack bus because we might have more than one buses which have the generator connected to them, but slack bus is taken as the bus whose generating capacity is the maximum. And for convenience, it is numbered as 1 in the system because numbering is also important in this load flow analysis. And for this case, we number the slack bus as to be number 1 bus. Now the PV bus or generator bus. This is also known as generator bus or PV bus. PV, what does this mean? Specified quantity is Pi and Vi. That's why PV, it is also known as P and V. So unknown quantities for this case is reactive power, injected reactive power, and this phase angle delta I. Generators are always connected to this bus, like we have generator connected to the slack bus. About 15% of the buses, of all the buses are PV buses. So the total number of buses is around 15%. If we have in case of this generator bus or PV buses. These buses maintain voltage constant as long as reactive power is within the limits. So PV buses will remain as PV buses, because PV buses means they have the fixed amount of real power and fixed amount of voltage. The voltage will remain fixed as long as reactive power supplied by the generator remains within its limits. If the reactive power goes away from its limits, it may not be able to maintain the voltage. So in that case, this reactive power limit is also specified, just to know that this reactive power is within its limit or not. If it is not within the limits, this will not be considered then the PV bus. It is again considered to be the third bus, that is the PQ bus. You will see that. The specified quantities are Pi and Qi. That's why it is known as PQ bus. P and Q are usually considered to be the load. So when they are specified, it means it's the load bus. Unknown quantities Vi and delta. So most of the buses you will see around 85% of all the buses are the load buses. At load buses there is no generation. PGI will be equal to 0, QGI will be equal to 0. There is no generating facility available. So one important point about this PV bus, you have to consider that reactive power should be in its own limits. If it goes away from its limits, we can take Qi to be the limited value. That is, if Qi is less than the Qi minimum, we can take Qi equal to Q minimum and treat this as a PQ bus. Similarly, if Qi is greater than Qi maximum, then we can treat this as a PQ bus, taking Qi equal to Q max. So these considerations are taken to be uh, in your mind. So the last one is the voltage control bus. It is actually a specific type of PV bus. Specified quantities are P and V, but here P is not having any non-zero value. Pi is a 0 and reactive power limit, exactly the reactive power limit as in the case of the PV bus. Unknown quantities are Qi and delta I. But what is the difference between the PV bus and this voltage control? There is no generator connected to the bus. Voltage is controlled by the tap changing transformer or by capacitor or by static power compensator, that is SVC, or by STATCOM, that is the static synchronous compensator. These are actually, these two are, this is actually uh, thyristor controlled capacitor, and this is static synchronous compensator using only switches. It imparts the it imparts only the effect of the capacitor or inductor in the system by using a switching mechanism. There is no capacitor present. Here there is a capacitor present and the capacitance varies as per the switching of the thyristor and by the tap changing transformer. Or we can have simply direct capacitor which are connected through the switches. Now these are the four different buses based on the unknown, based on the different quantities given. Now since the static load flow equations or the load flow equations are non-linear because of the presence of sine and cos, so we require an iterative method to solve it. You can see it from here. You can see it from here. You'll see because of the presence of this cos and this sine, these equations are non-linear, so we need some iterative method to solve it. We have here two methods to solve the load flow equations. One is the Gauss-Seidel method, another is the Newton-Raphson method. So we'll first discuss the Gauss-Seidel method. In Gauss-Seidel method, before going into the Gauss-Seidel method application to the load flow equation, we'll simply first solve another nonlinear equations in terms of x. Let us say we have an equation x plus cos x minus 3 is equal to 0. I can represent it like this: x is equal to 3 minus cos x. Now I will do this by Gauss-Seidel method by like this. I will assume an initial value to this x and then solve this and find the value of this x. You can see it, I have done this. This is the iteration number. This is the x naught initial value. I have assumed first the value of x is equal to 1. When you do this in the calculator, please change the mode to the radian mode. X naught, that is the initial value of the x. Here when we do the this iterative method, in that case we always start from an initial value. Here the initial value is x naught is 1. So updated value here when we calculate it is 2.4596, and the change in these two, you can see it will be equal to updated value, that is delta x will be equal to x1 minus x naught. So 1.4596, the difference of these two. So for the next iteration, I will give this x as the value of 2.4596. That is here. Now the initial value will be this, and I will calculate this. So its value comes out to be 3.7763, and the difference will be 1.3161. So in general, you can see I'm giving some initial value to this and getting the updated value for this x. So I can write it in terms of general form in terms of updated value. You can see that updated value will be equal to 3 minus cos of the, you can see the initial value, not initial value, which is the previous value. So this is the new value, this is the previous value in every iteration. In terms of r, it can be represented like this: x raised power r plus 1 is equal to 3 minus cos x raised power r. I can also do it like this. I can take this 3 to this, it will be 3, then minus 3 minus x. So x will be equal to cos inverse of 3 minus. In that case also, this can be represented as x raised power r plus 1 cos inverse 3 minus x raised power r, where this is the previous value, where this is the updated or new value. But here we have to take the consideration of this cos, because its value will lie between minus 1 and 1. So there will be limited value for this x. So in that case, it will be slightly difficult to use this equation, but to use this equation there will be no problem. So when we go for the newer values, for this case you will see that this delta x will come to 0. You cannot say it will come to 0, but it is diminishing. Its value goes close to 0 as we increase the number of iterations. So depending upon that, we can consider up to 3 place of decimal, 4 place of decimal. We can say this is the actual solution. 3.2 place of decimal, 3.79, it is solution of this equations. Similarly, for this case, x square plus 2x plus 1, we know that is the again nonlinear equation, quadratic equation. We have the formula for this, but we can calculate its value by using the iterations. So to make the Gauss-Seidel equation, I can write it like this: x raised power r plus 1 from this is equal to minus 1 minus x square. I will take minus common, x square plus 1 divided by 2. So first I will give the initial value to this and calculate the updated value from here. So that's why I have written over here, you can see it, x square r, that is the previous value, and here xr is power 1, xr plus 1, it is the updated value. So I can use this equation also. This is minus 1 minus 2x, take minus common, that is 2x minus 1, then take the square root on both sides, that is xr is r plus 1 will be equal to square root of minus 2x plus 1. But here also you can see that this square root has some limited values, it will not have any minus values, so it is better to use this as compared to this equation. But in general, you can take any x from this or this. You can take x from this x or from this x and calculate it by using the Gauss-Seidel method. So I hope you understood this, how to use the Gauss-Seidel method for a single variable and for other equation apart from the equation that we have used for load flow equation. Now coming to the load flow equation. So first, when the system has first we will do it for the load bus. When the system doesn't have PV buses, when the system has all the load buses except the slack bus, definitely we will use the reference bus will be there. So let n be the number of buses, the total number of buses will be n. Bus number 1 will be slack bus, as we have told earlier that the slack bus is usually numbered as 1. Bus number 2 to n will be PQ buses, so number of PQ buses will be n minus 1. So I write down the equation again, that is Pi minus JQi will be equal to Vi star summation j is equal to 1 to n Vj Yij. So when I open this up, it will be equal to V1 Yi1, because j will change, this I will not change, it will remain as it is. So V2 Yi2 plus that is Vi when j is equal to I, Vi Yii plus that is up to Vn Yin. So I multiply this Vi to this whole equation, it will be equal to Vi star V1 Yii plus Vi star V2 Yi2 plus that is when j is equal to I, Vi star Vi into Yii plus that is up to Vi star Vn Yin. I'll first write this term, that is Vi star into Vi Yii. I have written over here, plus then the same equations, same terms like this and this, that is Vi star I have written as first Vi Yii plus Vi star V1 Yi1 plus Vi star V2 Yi2 plus dash up to Vi star Vn Yin. Here we have one term where j is equal to I, but I have written that first and then written outside this summation. So again this equation will be Vi star summation j is equal to 1 to n Vj Yij. But here, since I have taken the term where j is equal to I out, that means here now j should not be equal to I. That term has been taken out. So this will be equation 7. Now this is the same equation, Pi minus Gqi. I will take this term to this side. It will be equal to Pi minus Gqi minus Vi star summation of j into 1 to n. J is not equal to n. I Vj Yij is equal to Vi star, that's this term, Vii Yi. Divide Vi star on both sides and try the left hand side on the first, on this left hand side first. First I will write this left hand side and I will divide Vi star. Vi star will go. It will be Vi into Yi. Vi into Yi. Pi minus Gqi divided by Vi star minus Vi star and Vi star will be cancel out. So it will be summation j equal to 1 to n. J is not equal to I. Vj Yij. So dividing Yi, so Vi will be equal to 1 by Yii. Pi minus Jqi divided by Vi star minus summation j is equal to 1 to n. J is not equal to I. Vj Yij. So this is the equation where we have calculated Vi. This equation is similar to this equation. We have calculated x in terms of some other x's. So we'll now give the initial value to this and then find the updated value in this case, and we will try to make equation like this. So this is where find out this. You can see equations are there. Here we have Vi, here we have Vi. Here also we can say if we have some Vj's which are present in this, but Vi is here, Vi is here. One of the Vi has been taken to the left, which can be calculated in terms of Vi over here. So before going into that, we just want to make the equation in this form, that is updated and the previous value. Now I'll first open this equation, this summation term. So Vi will be 1 by Yii Pi minus Gq Vi star is the same term. This will be V1 Yi1 plus V2 Yi2 plus dash Vi minus 1 Yi I minus 1, because here j is equal to I minus 1, plus Vi plus 1 Yii plus 1. This is the second term from this. Dash up to Vn In, because here in between these two we have a term Yi Vi Yii that has been taken to this. That's why I have shown you these terms. From this first term and second term, they will be definitely this separated by Vi, but that Vi has taken to this side. So let us say we have 10 bus system and Vi is the, let us say, fifth bus. So when we calculate first for bus 2, then bus 3, bus 4, and when we reach to bus 3, we must have already calculated for bus 4. So in that case, what I mean to say is that up to bus 4 we have to use the updated value, and from bus 5 to bus 10 we have to use the previous values. So that is why I have written it like this. I can write them in the summation form. It's again equal to Vj is equal to 1 to I minus 1 Vj Yij. Here we must have calculated up to 4 bus system. Up to 4 bus the voltage have been already calculated. That's why I have written here updated. We can use the value of Vj as the updated value. Here also the previous initial value or previous values. For different iterations we can use the previous values. So I can write it as like this, because Vi is the fifth bus, we have to calculate it, we have to use it here, we have to use it the previous value to calculate the updated value. But the buses which are up to 4, that is up to I minus 1, we have to use the updated value, that is Vj will be R plus 1 in R. And this is the equation which we have used. Equation 9 is used to calculate the voltage at the ith bus by iterative method. We'll come to this when we do the numerical, but I hope this is understood to you, and I'll stop over here. Thank you.